Students, very good afternoon to one and all. How are you all? Can you able to hear my voice? Am I audible and visible to all of you? Yes, good afternoon, Samana. Good afternoon to all. Okay. So, yesterday, I think Sir might have discussed the first order integrated rate equation and the graphical representation and some information about half-life. Am I right? So yesterday you guys have gone through that part only, no? Say yes or no? We have discussed about the half-life part, right? Integrated rate equation and half-life. Students, am I right or wrong? So one of you just let me know. So I think most of you were there in yesterday's class also. Just let me know if sir has completed the half-life part. Okay, fine. Yeah, thank you, Jyoti. And I'm going to ask you a question from the half-life. Okay, very simple question only. So what is the half-life formula for first order reaction? How will you find out the half-life for first order reaction? Can anyone give me the answer for this question? What is the half-life formula we use for first order reaction? So all of you can try for this. Jyoti, Sanjana, Sanika, Vikas, Sakshi. Anita, Vaishnavi, Pratyusha. So students, tell me what is the formula we used to find out the half-life or first order reaction? It's a very easy question, no? So you might have discussed the formula yesterday, right? Sir might have taught you. What is the formula we used to find out the half-life for first order reaction? Is the half-life dependent on the initial concentration or independent of the initial concentration for first order reaction? 0.693 divided by lambda. It is not lambda, my dear. It is K. Okay. It is the rate constant. K. It is not lambda. It is K. Okay. Clear? So the first rate half-life formula for first order reaction is T half is equal to 0.693 divided by K. So this is the formula to find out the T half for first order reaction. Okay. So here in this equation, you can see that we don't have any concentration term. So for first order reaction, T half is or the half-life is independent of the initial concentration. Okay. But if you look into the formula for zero order reaction half-life, there you can find out the concentration terms in the numerator. Means the T half for zero order reaction is dependent on the concentration. Okay, so these points are very important from the half-life. Other than that, two formulas. So these two formulas are very important. And graph also he might have taught you, I think. So the graph for T half versus rate constant and T half versus not versus rate constant, T half versus concentration graph. Okay, T half versus concentration graph for half-life. Okay, for both first order and zero order. So they are very important. So two graph, two formulas, and this independent concept. Okay, so these are the points you have to keep in mind regarding this T half. Okay. And before that, we have discussed the integrated rate equation for zero order, and yesterday integrated rate equation for first order would have been discussed by the sir. And from that also, derivation part is not required for NEET and JEE. The last formula is very important. Okay. So the rate constant formula and integrated rate equation formula and the graph. So these three things are very, 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 very important. Okay, for zero order and first order. So only for these two orders, you study. You don't have to study for second order and all. Okay, so it is not in our syllabus. So we can go with these two. Got it. Now, today we are going to discuss about pseudo first order reaction. What it is? Pseudo first order. So can anyone give me the meaning for pseudo? Do any of you know the meaning for pseudo? What is meant by pseudo? Have you heard of this term before? Imaginary. Okay. Imaginary. Very good. We can also say false. Okay. Pseudo means false, etc. etc. Yeah, false, imaginary, kind of. So what is meant by pseudo first order reaction? The given reaction is not a first order reaction, but it is called to be a first order reaction. Okay. So those reactions are called as pseudo first order reaction. Okay. Don't get confused. We will see this with a clear explanation. Okay. So let's start with pseudo first order. So the bimolecular reactions. Bimolecular means only two reactants should involve. So bimolecular reactions following the rate equation of the first order reaction are called as pseudo first order. If we are having two reactants, then the order should be two. Okay. But bimolecular, but it is a first order reaction. Okay, then it follows the first order rate equation, means then it is a pseudo first order reaction. So let's see an example so that you can understand it better. So the first example is inversion of cane sugar. Okay, so cane sugar means it is a sugar cane. So sugar cane contains sucrose. So what is the formula for sucrose? C12, H22 and O11. Okay, so this is the cane sugar which is called as sucrose, and we are going to hydrolyze this. Hydrolysis means addition of water. Okay, so if we hydrolyze this cane sugar, we will get C6H12O6 glucose and C6H12O6 fructose. So glucose and fructose both will have the same molecular formula, but there will be different functional groups present in both. Okay, so they are the functional isomers of each other. So that's why they are having the same molecular formula. So what is happening here? We are taking two reactants. One is sucrose and the other one is water. Means the rate of the reaction, order of the reaction should be 2. But if you see to the rate equation, so rate is equal to K into the concentration of cane sugar and into the concentration of water. But if you see to the order, only sugar cane is having, sucrose is having order 1 and water is having the order 0. Okay, so the total order of this reaction is 1. So actually it is a second order, but it is a called as a first order. So it means it is pseudo first order reaction. So why? Why we are neglecting the concentration of this H2O? Why we are neglecting the concentration of this H2O? So any idea for anyone? Any idea? Do any of you have any idea that why we are not taking the concentration of H2O into account here? Why we are putting 0 there? Any idea? Do any of you have? Yes or no? Say something, my dear students. If you say yes, then I will ask you the explanation. If you say no, then I will proceed. Okay, Sakshi. So fine. So I'll proceed. I'll tell you. We are neglecting the concentration of H2O because it is present in excess. Okay, it is a water, no? So it will be presenting in excess amount. So if something is present in very, very excess, we will not take that particular concentration of that excess substance. Okay, because using that excess amount, we cannot able to determine the speed or the rate of a particular reaction. So what we will do, we will neglect the component which is present in very excess. So since water is an solvent, universal solvent, and it will be present in very large amount, so it will be present in very excess amount. So we are not considering the concentration of water in the rate equation. Clear? So this is the reason. I hope you guys have understood this. Yes? Or any doubts here? Now you understand no why inversion of sugarcane is called to be a pseudo first order reaction and why we are neglecting the concentration of H2O. Okay, okay, good. So now let us understand this pseudo first order reaction taking one more example. Okay, acid catalyst ester hydrolysis. So what we are basically going to do, we are going to take an ester and we are going to hydrolyze it. Hydrolysis means take an ester and add water to it in presence of acid. So that acid will act as the catalyst. Okay. So to take an ester, what is the formula for ester? R C O O R. So this is the ester. So both R can be same or both R can be different. Okay. So this is the functional group for ester. Now I am going to take one ester, CH3, COO, C2H5. Okay. You want to write the definition for pseudo first order reaction? Okay, my dear. I'll show you the slide. You can take down that. So in the first slide, I have given, so this is the definition. So take down this definition and including to this, you can add the two examples which I am teaching now. Okay, first example is inversion of cane sugar with equation, and the second is the acid catalyst hydrolysis of ester. Okay, so what is pseudo first order reaction? Give example. This can be a question for your school exam. But if you go for NEET and JEE, they will give you one reaction. They will ask you to find out. They will give 4 reactions. They will ask us to find out which one is a pseudo first order reaction. So that kind of questions you can get for NEET and JEE. Okay. Sakshi, just let me know once you are done with it. Okay. So this okay is for what you have completed. Done. Okay. Very good. So take down the formulas. Take down the examples also. I think you have taken down this example. Yes or no? Inversion of cane sugar example. Have you taken this? Okay, fine. Acid catalyst hydrolysis. So I am taking an ester. So this ester has methyl group as R group and ethyl group as R dash. Okay. Now we are going to hydrolyze. Hydrolysis means addition of water in presence of acid. Acid contains H plus, right? So acid is the catalyst here. Got it? Now here what you do, what we will get two compounds. One is acetic acid and the other one is ethanol. So this bond will break. We have to add H here and OH here. Okay. So using this addition only, we will get these two compounds, carboxylic acid and alcohol. So they are the products. But if you see to the reactant, we have two reactants. One is ester and the other one is water. But the rate of the reaction depends only on the concentration of ester. Concentration of water is taken to be 0. Okay, but concentration of water does not get altered much. Hence, what we are doing, we are neglecting that and writing the rate equation like this. Okay, so K dash into concentration of H2O is nothing but K into concentration of ester. So the name of this ester is ethyl ethanoate. Okay, ethyl ethanoate. You can take any ester, no problem. Got it? So here we are neglecting the water because of the same reason, because it is present in very excess. Inversion of cane sugar and acid catalyst ester hydrolysis. Clear for all of you? The pseudo first order reaction and their examples. Do any of you have any doubt? Okay, only Sakshi is responding. What about others? Oh, very good students. Thank you. So now let's go with some MCQs. The following is the first order is pseudo first order reaction. The following is pseudo order reaction. Base hydrolysis, inversion of system, acid hydrolysis of ester, both B and C. Which is the answer? So many of you are giving option B and C. So which is the correct answer? The following is pseudo first order reaction. So the correct answer is option B. So both B and C. Inversion of system means inversion of that sugar only. Okay, that sugar is the system. Okay, inversion of sugar and acid hydrolysis of ester. So these two are the examples for pseudo first order reaction. Okay. So now we are moving into the next topic, which is the factors affecting the rate of chemical reaction. Okay, so already we have discussed some roughly. Okay, now here we are going to see very detailed factors affecting the rates of the chemical reaction. So the first factor is concentration and pressure. Second is nature of the reactant. Third factor is temperature. Fourth factor is light. And the fifth factor is catalyst. So these five factors are going to affect the rate of a chemical reaction. And we are going to see how it is going to affect the rate. Okay. Whether if we increase a particular component, will the rate get increased or will it get decreased? So that thing we are going to see. So let's move on to the first. So the first factor is concentration and pressure. So with respect to rate, the rate of the reaction, it is directly proportional to the concentration of the reactant. So what is the meaning for this? What is the meaning for this statement? Rate is directly proportional to the concentration means what is the meaning? If I increase the concentration, the rate will also increase. If I increase the pressure, rate will also increase. If I decrease the concentration, rate of the reaction will also decrease. Okay. So that is the meaning. Got it. So if the concentration is more, means reactant molecules will be more. Concentration is nothing but the strength, no? So higher the reactant concentration leads to a higher chance of collision, which leads to higher the rate of the reaction. Okay. So what happens when the number of particle is more? Here you can see that in the picture. So if the number of particle is more, then we are saying that the concentration is more. So in that case, two molecules, they are colliding with each other very, very fast and more high chance of collision is being happening. But if you see to the low concentration area, we have only very fewer number of molecules and the collision is also very less. Number of collision becomes very less for low concentration thing. So in that case, rate will also be very less. Okay, and the speed of the reaction will be very less. Got it? So that's why rate is directly proportional to the concentration. Clear for all of you? So why the rate is increasing? if the concentration increases? Because the number of collision increases. So that's why rate is increasing. Clear for all of you? Any doubt? Okay. Now moving on to the second factor. Okay, students. So the second factor is nature of reactant. Okay. So the nature of the reactant is dependent on the surface area. So if the nature of the reactant, here you can see in the first case, the reactant is looking like a powder. Okay. And in second case, it is looking like a solid. Okay. So in case of solid and in case of powder, you tell me which one will have the largest surface area? Which one will have the more surface area? Solid or gas? Sorry, powder. Powder will have the largest surface area. What my dear students? Larger the surface area of the reactant, larger the surface area of the reactant, faster is the rate of the reaction. Okay, faster is the rate of the reaction. So if you take a powder, you will have only very small particle. But if you take a solid block, the surface area for that particular block will be more, no? Okay. Okay, don't get confused with this. If the surface area is more, then the reaction will occur very fast. Okay. So the surface area is rate is directly proportional to the surface area. So this is the point you are getting from this. Okay. The third thing is the temperature. So what is the relation? So rate is again directly proportional to temperature. Rate is directly proportional to temperature. So if you increase the temperature, increase in temperature increases the rate of the reaction. Okay, so why it is increasing? Why if I increase the temperature, rate is also increasing? I'll show you with the picture. So you see here. So there is a container and some molecules are present inside it. Now, if I increase the temperature, if I burn this, what is happening? The molecules which are present inside the container, they are moving here and there very fast. So in that case, what will happen? The collision between the two molecules will be very larger and the reaction will occur fast and we will get the product very fast. Okay, so you by this only the rate of the reaction is getting increased on increasing the temperature. Clear for all of you? Clear for all of you? So this is the concept. We can also study this by using the kinetic energy form. So here the mass of the molecule and the velocity of the molecule, mass remains constant. The velocity means the speed of each molecule is increased. It is getting increased on increasing the temperature. Okay. So what will happen to the kinetic energy? Kinetic energy is nothing but half mv square. Mass is constant. Velocity is increasing. So kinetic energy and the velocity, they are directly proportional, no? So if velocity increases, kinetic energy also increases. If velocity increases, kinetic energy also increases. Okay. So more kinetic energy is equal to more violent collision. If kinetic energy is more in a particular container, then we can say that the collision is very violent. Okay. So more number of collision is happening inside the container. So more collision means they are very successful at high temperature than at low temperature. Okay. So the reaction rate is almost double for every 10-degree rise in temperature. Reaction rate is double for every 10-degree rise. So if I increase the temperature of the system to from 60 to 70, the rate will double. If I'm increasing from 70 to 80, it will still get double. Okay, so like this only the rate is affected by the temperature. Okay, so that is denoted by temperature coefficient, which is equal to the rate constant that is T plus 10 degrees Celsius divided by rate constant at T degree Celsius. T means temperature. Okay. Clear for all of you? These are the formulas. These are the concepts which you have to understand. Okay. Only then you can be able to attend the assertion reason type and the theory type of question, statement type of question, conceptual questions. So those questions can be answered only if you understand the concept. Clear? Can we move on to the next slide? Do any of you have any doubt? Everything is clear so far, no? For all of you? Okay. Now let's do some MCQs and then we will jump to the fourth factor and fifth factor. Okay, so what are the three factors which we have discussed? First is concentration and pressure. Second is the nature of the reactant. Third is the temperature. So in all these three cases, the rate is directly proportional to the corresponding factor. Okay, rate is directly proportional to concentration, rate is directly proportional to temperature, and rate is directly proportional to surface area. So very easy. Now coming to the first question. At higher concentration of reactant, the reaction goes slow, fast, no difference, all of these. At a high concentration, the reaction will occur very fast or it will occur very slow or there is no difference. Sanika, Mahit, Sakshi, are you sure? Option B is the correct answer. Okay, everybody is saying option B. So it should be the correct answer. No? So option B is the correct answer. So higher the concentration, higher is the reaction rate. So it will occur very fast. Very good, students. Now let me go to the second question. Concentration of reactants has no effect on rate of the reaction. So this is a statement. Okay, you have to tell me whether it is true or false or we can't say and none of these. What is the answer for this? Concentration of reactants has no effect. B, option B. Yes, so this statement is false. Okay, it has some effect. It has directly proportional relation, no? So it has some effect. So the statement is false. Third question. Temperature affects the rate because reaction changes, molecules get more energy decreases, none of these. The temperature affects the rate because okay, again everybody is going for B. Vaishnavi, Rutuja, Mahir, Sakshi, Jyoti, everybody is going for. Very good, students. Option B is the correct answer. So molecules get more energy, okay, because of the kinetic energy increases. So the temperature is getting affected. Temperature affects the rate by this factor. Okay. Fine, we'll move on to one more question. Rate of the reaction is directly proportional to amount of the reactant, temperature, size of the vessel, all of these. All of these. Only one person have given the correct answer for this question. Who is that person? It is Vaishnavi. Yeah. What happened to others? Mahit is giving me correct answer. So correct answer is temperature. Okay, temperature. Rate is directly proportional to temperature. It doesn't depend on the size of the vessel. No, surface area means surface of the reactant. Okay, not the container size. So the answer is option B. Now next is on increasing the temperature, the kinetic energy often decreases, increases, both A and B, none of these. What will happen to the kinetic energy? Okay. Yeah. The correct answer is option B. Very good. Very good. So it is the correct answer. Great students. So I'll go with one more question. For every 10-degree rise in temperature, dash the rate of the reaction. Doubles, triples, does not change, none of these. Option A. Very good. Answer is option A. For every 10 degree, so the rate of the reaction is getting double. Very good. So, with this, I am closing this factors affecting till the third factor. Now we will move on to Arrhenius equation. Okay, after going through some concepts of this Arrhenius equation, we will come back to the fourth factor again. Okay, so Arrhenius equation. Arrhenius is the name of the scientist. Okay, so he says that, so this concept is about the temperature. So that's why I'm discussing under this temperature factor. Okay, we'll complete this and then we will move on to the fourth factor. So the temperature dependence of rate of a chemical reaction can be explained on the basis of Arrhenius equation. Okay, so for what we are using this to understand the temperature dependence of the rate of a chemical reaction. Okay, which is very, very important. Now the Arrhenius equation is, so this person is Svante Arrhenius, and the equation is K is equal to A into e power minus EA by RT. Okay, this is the Arrhenius equation, which is very, very, very important. Okay, so we should know the terminologies, right? So here the K is called as rate constant. We already know, right? K is nothing but rate constant. And EA is called as activation energy or energy of activation. Okay, and R is nothing but the universal gas constant. T is the temperature in Kelvin, and A is the Arrhenius factor, or we can call this as frequency factor or pre-exponential factor also. So A has three names: frequency factor, Arrhenius factor, pre-exponential factor. Okay, so try to memorize this equation and understand all the terms, letters involved here. Clear for all of you? Did you all take this equation in your notebook? Shall I move on to the next part? Okay. Yeah. Here A is the Arrhenius factor. Now we are going to do a graphical representation for this Arrhenius equation, which is K is equal to A into e power minus EA by RT. So just by seeing this equation, we cannot draw a graph. So what we have to do, we have to convert this equation to a straight line equation format. So for that, we have to take log on both the sides. So taking log on both the sides, what you will get? Log K is equal to log A plus log of e power minus A by RT. So what I have done, I have A into this entire term. Log of A into B is equal to log of A plus log of B, right? So that is what I have done. So here A is the capital A, Arrhenius factor, and B is the e power minus A by RT term. So is it clear for all of you that how I have applied log for both the terms? Any doubt in the mathematical part of this? Shall I move on to the next step? Okay. So now the next step, log K is equal to log A minus E by R. So where does this log and E goes? Logarithmic function and exponential function. They are like plus and minus. Okay, they will get cancel each other And in the numerator, we have, in the superscript, we have minus EA by RT. That will come here as a coefficient. Okay. So minus EA by RT into log E. Log K is equal to minus EA by RT, R into 1 by T we can say, plus log A. Just I have taken this term here and plus log A goes, that's all. Now, this particular equation, the last equation is of formula y is equal to mx. So m is the slope, you can see. So it is minus a by r. So that is the slope and 1 by t is x. Okay. Plus c is the intercept, which is nothing but log a. So the last equation after taking the logarithmic function on both the sides is of the format of straight line equation. So what I can do with this equation, I can draw a graph for x-axis and y-axis. So x-axis is taken as 1 by t, and y-axis is taken as log k to the base e. So log k versus 1 by t graph I am drawing. So what was the slope we have seen? It is minus EA by RT, right? So it is a negative slope. So the line has to come from top to bottom like this. Okay. And this is the slope for this equation, which is nothing but minus EA by R. And the intercept means the line which intersects cuts the y-axis. Okay, that point. So this point is called as intercept. That intercept is nothing but log A. Okay. So here minus EA is nothing but minus R into slope. Activation energy is equal to minus R into slope. Okay, you can rearrange this equation, get this relation. So you should know what is an intercept and what it is. And you should know what is slope here. And the slope is negative, and that's why line is coming from top to bottom. And you should know the x-axis and y-axis also. Clear for all? No doubt? Okay. Now I'll go with one more graph. Potential energy versus reaction coordinate. Okay. So first of all, I'm going to I will be having a reactant, and reactant will be converted to a product. Okay, so it follows this pathway, and it is finally getting converted into a product. And the topmost peak point for this particular reaction, okay, in that topmost point, if you see, the activated complex will be present, or I can say at that particular point only the reactant molecules have got activated. Okay, so now that point is called as transition state. That point is called as transition state. So the distance between the transition state and the reactant is called as activation energy. So what does this reactant do? The reactant has observed this much of activation energy and it has got activated. Okay, reactant has got activated. Now, this is the reaction coordinate versus potential energy graph. And after that, so after getting activated, the complex, the transition state, a molecule cannot exist in the transition state for long. So what it will do, it will break down into product so easily, and it will be converted to a stable product soon. Okay. So now with this, we'll see one relationship between rate constant at two different temperatures. So is everything clear for all of you? What I have discussed so far is okay and clear now? Do you have any doubts from Arrhenius equation and the terminology is involved in Arrhenius equation and the straight line equation for Arrhenius equation and the graphical representation for Arrhenius equation? So any of you have any doubt from these parts? No doubt. Okay. So now we'll go for the relationship between rate constant at two different systems. So far we have studied for one system at one temperature. And we'll go with the rate constant at two different temperatures. So first of all, take Arrhenius equation. And if you take log on both the sides, you will get an equation like this. And it will give us this particular equation, y is equal to mx plus c. Now what I'm going to do, so now it is a formula log to the base e, right? So if I want to remove that base e, I have to include 2.303 constant. Okay, that will be equal to 2.303 into log A. I'm removing that base E minus EA by RT. Okay, minus EA by RT. So log K is equal to log A minus EA by 2.303 RT. So why 2.303 have come here? I have divided this entire equation by 2.303. Have divided this entire equation by 2.303. So when I divide with this left hand side, so we get cancel out each other. So I'll have only log k. Here also the same case. And here if I divide, I will get that number in the denominator. So it has gone to the denominator. Okay. Now the temperature is there in the denominator and the rate constant k is there in the numerator. So what is the relationship? So here it is minus EA. It is minus EA. So if it is minus, then it is in directly proportional relationship. Then it is in directly proportional relationship. Suppose if I have two temperature, I will have T1, T2 and K1, K2. So this is the equation for K1 and T1, and for T2 is equal to K2, then I will have this particular relation. Okay. So for the same reaction, we may have temperature as T1 as well as T2. Here, you need to just understand the final formula. Now what I'm going to do, take this two equation, log K1 and log K2. Okay, log K1 and log K2. Try to subtract. So what we will get? Log K2 minus log K1 is equal to, so substitute all the terms of K2 and K1. So minus EA by 2.303 RT2 plus EA by 2.303 RT1. Final minus initial. So here logarithmic function is of formula log A minus log B, right? So it is equal to log of A by B. Log of K2 by K1. Okay, A is K2 and B is K1. So log K2 by K1 is equal to, so bring this term to the, or you can take EA by 2.303 R out because it is the common term for both. And we can include 1 by T1 minus 1 by T2. 1 by T1 minus 1 by T2. Okay. Now log K2 by K1 is equal to EA by 2.303 R T2 minus T1. You can take the LCM. You can take the LCM T2 minus T1 divided by T1 into T2. So here if you see to the temperature, the final temperature will always be greater than initial and the final rate constant will also be greater than the initial rate constant value. So the last equation, this will be very helpful in solving the numericals. Got it? And this will come in theory part. If I increase the temperature, what will happen to the rate constant? So that kind of question can be asked. So any doubt? Do any of you have any doubt? Is everything clear and okay? No doubt. Okay. So let's do an MCQ. Which of the following equation gives the relation between rate constant and collision frequency? Which is correct for rate constant and collision frequency? Option A. Why Jyoti is getting option B? It is K is equal to A into E power minus EA by RT, no? Mahit. Yeah, Mahik is giving me the correct answer. Who's the other person? Sanika. Sanika, why you are going for option B? It's not option B, no. Jyoti and Sanika, it is option A. Okay. Okay, good. What is the slope of the graph obtained when we plot log k versus 1 by t? Oh, by mistake you have said. Okay, no problem again. So what is the slope of the graph obtained when we plot log k versus 1 by t? Option is, correct answer is option A. The slope value, m value is minus EA by R. Okay. So for the third question, you try. What is the y-intercept of the graph obtained when the plot log k versus 1 by t? What is the y-intercept of the graph? Log a minus log a, both a and b, none of these. Which option A? Very good. Option A is the intercept. Okay, it is the y-intercept which intersects the y-axis. Very good. Now the next question is, in the equation which relates K at two different temperatures, which of the following is taken as the higher temperature? Okay. So if we have two different temperatures, you have to tell me which one will have the highest temperature. T1, T2, either T1 or T2, none of these. Option B, sure, very good. So the answer is option B. Okay. And next is again, I'm going to give you one more example for Arrhenius. So H2 plus I2 giving 2HI equation. H2 plus I2 giving 2HI. So according to Arrhenius, if you see, this reaction require certain energy to get active, which is called as activation energy. So every time we cannot expect that two reactants will react with each other and they will form the product always. Sometimes they require the higher amount of activation energy also. Okay. And for this particular reaction, activation energy is required. Here, just see the graph versus reaction coordinate and potential energy. So here I have a reactant and here is the product and the curve goes like this. And this is the activation of energy. Okay, activation energy we can call. And this point is called as the difference between the reactant line energy and the product energy is called as delta H. Okay, very important to solve the problems. So this is nothing but delta H. Delta H is equal to eigenfinal final minus initial only. Now all the molecules in a different reacting species. Students, can you able to hear my voice? Yeah, okay. So all the molecules in the reacting species, they do not have the same kinetic energy value because the velocity of each particle will differ and the mass of each species may differ. So different molecules will have different kinetic energy. Okay. So if the kinetic energy differs, everything will differ. No. So here only two scientists, they are coming, Boltzmann and Maxwell. Okay, they suggested the behavior of large number of molecules, Boltzmann and Maxwell. So we will discuss these two persons' concept in the next class. Okay, we'll discuss what they have said and we'll discuss the formula we are going to get from this two people concept. Okay, so what we have discussed today? Today we have discussed yesterday we have completed the half-life. And today, mainly the factors affecting the reaction rate we have discussed. And before that, pseudo first order reaction and the two examples. The next thing is factors affecting the rate of the reaction. Three factors, five factors are there, and we have discussed three. Okay. So, concentration, nature of the reactant, and temperature. So, and after that, we have been discussing about the Arrhenius equation and its terms and the relations. They are very important. And then next class, we can move on to the next last topic of this lesson. Okay, so do you have any doubts from this today's session? Do any of you have any doubts here? No? Okay. Thank you so much, students, for listening the lecture. See you all in the next class. Take care.